Welcome back, Algebra 1 students. We're in lesson 52 today, and this is where we are seeing some repetition. We're going to go back to the beginning and talk about the denominator-numerator same quantity rule. All that means is that if we have 1/2, that we can multiply the denominator and the numerator of a fraction by the same non-zero number. In this case, let's say 4. So we can multiply the top and the bottom, the denominator and the numerator, by the same number, and it does not change the value of the fraction. So 4 times 1 is 4. 2 times 4 is 8. 4/8 is still the same as 1/2. We recognize that we can reduce this to be the same as this. That's all this says. And we learned that long time ago, at the very beginning of, probably in pre-algebra for most of you, but we went over it again at the very beginning, the first lesson or second lesson of this year. So we're just reiterating or restating this rule so we can be reminded for the problems we have coming up today. That's all we're doing. So be sure you put this in your notebook to remind yourself of this fact, and give yourself a example like this one will work, where you show what that means, right? That we are multiplying by the same number on the top and the bottom, and that these two are then equal to one another. All right, that's all we're doing, that this one equals this one because they are multiplied by the same number on the top and the bottom. So I gave yourself this little bit of notes, and then we'll move on. All right, I'm going to clear the page. So let's talk a little bit more about the addition of rational expressions with unequal denominators. And then we're going to talk about overall averages. So let's jump into example 52.1. We have a over x plus b over x plus y. So we need to find a common denominator for this, right? So the easiest thing to do when we have all these weird variables and we need to find a common denominator is just to multiply them times each other. So that's what we're going to do. We're going to set our common denominator as this denominator times this denominator. And we're going to set up our fraction just in the same format it's set up here, but just with the new denominator in the bottom. Okay? Now what we're going to do is we are going to multiply this side by this denominator, just like we always do to find a common denominator. So we're going to say a times x plus y. And then we're going to multiply this by this. So x times b. And that is going to be our solution, or our start to the solution of this problem. So now what we need to do is distribute. So we have to distribute here. But the first thing we're going to do before we distribute is we're going to write this all as one fraction. Now that they have a common denominator, we can do that. We can say x times x plus y. And now we can distribute. A times x is ax. Bring down our operator. A times y is ay, and then we have plus, and then x times b is xb. And that's how we would solve this. This is the solution to this problem. That's as far as we can go. All right. The only other thing that we could do is distribute x times x and x times y and get x squared plus xy. So that is an option. don't have to do it. X times x is x squared. X times y is x, y. That is another possible solution to this problem. Either one is right. Let's do example 52.2. We'll do it right over here. Move my paper over a bit. All right, we have 4x plus a over a plus b plus c over x. So I would like for you to pause this video, work the problem, and come back and see if you have the same answer I do. All right, so if you did all the distribution that you could do, once you found your common denominator and did your multiplication, you should have gotten this as your answer right here. 4x squared plus ax plus ca plus cb over xa plus xb, or over x times a plus b. Either one of these is correct. This is as far as you can go, and this is almost as far as you can go. It's right next door. But what we did was I took these two denominators and I multiplied them against each other, which gave us x times a plus b as your denominator, the common denominator. So then I looked at this fraction and I said, well, I already have a plus b here, so I need to multiply everything by x in order to get that common denominator. So I multiplied the top and the bottom by x, which gave me x times 4x plus a and x times a plus b. And then over here, to get the common denominator, x times a plus b, I had to multiply everything times a plus b. So I multiply the top by a plus b, and I multiply the bottom times a plus b. That reminds you of the rule we went over, right? That's what we've been doing. So now that they both have the common denominator, I could write them as one fraction, and when I did that, I went ahead and I distributed. I said x times 4x was 4x squared, x times a is ax, plus c times a is ca, and c times b is cb, all over the same denominator of x times a plus b, which is xa plus xb. And so that's how we got the solution to 52.2. So let's look at 52.3. And that one says a plus b over x plus c over m plus d. So our first step is to make sure that we find a common denominator, correct? Well, d is not a fraction. It doesn't have a denominator. So we change it. We change it into a fraction by putting it over 1. Now we can find a common denominator because they're all fractions. It's obvious our common denominator is going to be x times m. 1 in front of a variable is always invisible, so we don't even have to include it. It's just there automatically. So we set up our fraction just like it is illustrated above. We have 3 fractions that are all added together. We put xm under each one. All right, so what we're doing now is we're going to multiply this entire fraction by this denominator m, so that it is a common denominator, but when you multiply the top and the bottom by m, you keep the value of this fraction the same. So we're going to say m times a plus b. We're going to do the same thing for this fraction, only this time we're multiplying it times the denominator of x. So we're going to say x times c is xc, and x times m gives us xm, which is our common denominator. Now d does not have an x or an m under it as a denominator, so we need to multiply the top and the bottom by both x and m. So we end up with dxm because we multiplied d times x and m, and 1 times xm is xm. So now that we have the same denominator under everything, we can write it down here as one big fraction. And we're going to do all the distribution we can do as we transfer it. M times A is MA. M times B is MB. And then we have XC. And then we have DXM. And that would be our final solution to this problem. And that one's pretty easy. So let's do another one. Let's do 52.4. I'm going to let you guys do this one. Practice on this. We have A over B plus C. We have a minus X and plus D plus M over K. All right, I want you to pause the video. Pause the video and work this out and find your solution, and then check back and make sure it's the same as mine. All right, you should have ended up with a very long problem. Ka minus xkb minus xkc plus bd plus bm plus cd plus cm all over kb plus kc. So here's how I got all of that, in case you're wondering. So we figured out the common denominator was bc times k, which I wrote like this, and I did my 3 fractions with the common denominator. This, I multiplied the top and the bottom times k to get the right denominator. I had to multiply the top and the bottom by both k times bc, because this was over 1. It was a fraction, or it was a whole number, x by itself. So I put that over 1, and I multiplied the top and the bottom times k times b plus c. And then I had the third one, which was d plus m over k. I had to multiply the top and the bottom times b plus c in order to get the common denominator. So when I went to rewrite this as one fraction, I did my distribution. On the bottom first, I did k times b plus k times c. Okay, so on the top here, I had ka for this one, and then I had a minus sign. And remember, when you have a minus sign, it's the same as putting a -1 in front of whatever this is here. So xk times b was xkb, right, within the bracket, plus xk times c, which was xkc within the bracket. So -1 times this gave me a negative xkb, and a -1 times xkc gave me a negative xkc. That's how I got the 2 minus signs. Plus b times d is bd, right? B times m is bm. Then you have c times d, which was cd, and c times m, which was cm. And that's how we got all of this. And that is the correct answer. If you did not get that, take a minute, go back and look at it and see where you might have made a mistake. Let's see if we have one more. We do not have one more like that. All right, so that's the last of those. Now we're going to talk about something called overall average. Let's clear the page. An overall average is where you have several averages and you need to figure out the overall average. The average of the average is seldom the overall average. Suppose the average of the first 6 numbers. So we have 6 numbers, and their average is 8, right? Then we have 4 numbers, and their average is 10. If we were to take both of these averages and say 8 plus 10, add them together and divide them by 2, if we were to get the average of these two averages, we would get 18 divided by 2 equals 9. But that's not accurate. That's not, we can see that that can't be the average because we have 6 numbers over here and only 4 numbers over here. So they're not evenly distributed. And if they're not evenly distributed, then we can't get an overall average between the two of them. So what we have to do to get an overall average is we have to work backwards a little bit. We have to figure out what the total sum of this was before we calculated the average. And the way you do that is you take the number of numbers, multiply it times the average. So 6 times 8 equals 48. Okay? And we have to do the same thing here. 4 times 10 equals 40. Now we are going to put those together. Okay? We're going to take the sum here and the sum here and add them together. 48 plus 40. That gives us 88. That is our total number of all the numbers. That's our total number. Because we have 8, 8, 8, 8, 8, 8. We have 6 8s here. And we have 4 10s here. Right? So we have, if we added all of these up, we get 88. You see that? I'm sure you see that. So now that we have 88, now we need to divide this number, 88, by the total number. I was about to do long division for a second. We need to divide 88 by the total number of numbers. So we have 6 here, and we have 4 here. That's 10. 6 plus 4 is 10. If we counted them, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So if we divide this by 10, we get 8.8, which is not 9. It's different from 9, especially if you're talking about a system where decimals are important. We don't know if the decimals are important. They might be. So we want to have an accurate average. All right. So that is how you find an overall average. We have to back out this number by number 1, multiplying the quantity for each average times the average. All right, so that's quantity times average for however many averages you have. Then we add the products. So we're going to say whatever this product is, we're going to add that to all the other products. So we added the product of 48 and the product of 40 together, and we got, or 48 and 40, and got 88. So we added the products. Then we divide by total items or numbers. Or values. And in this case, we had 6 over here and 4 over here, which gave us a total of 10. All right, that total of 10, that was step number 3. This was step number 2. This was step number 1. So we multiply, then we add the products together, then we divide by the total items. 6 plus 4 is 10. Now there's an easy way to set this up. I'm going to scooch this over just a bit. You can set this up by saying 6 times 8 equals 48. This is your quantity, right? And this is your average. And this is your product. And you take the second one and you do the same thing. You say we have 4 numbers that had an average of 10. Their product is going to be 40. So then you can take this and add it together. But you want to take the quantity and add the quantity as well. So now you need to take this number here and divide it by this number. So that goes under here. And then this would be your overall average. So there's a way to set it up that is less writing than all of this. Okay. Just an idea here. This is the way that I do it because that's the way my brain sees it. And that's the way it makes sense to me. When I have a table or a structured way to do something, then I know I just have to fill in the blanks. It makes it a whole lot easier. And if you have more than 2 averages, you just keep making this list, you just add more rows to the list. And it's easy to adjust for bigger problems. But it's still the same thing. Quantity times average equals product. And then because they're stacked on top of each other, it makes them easy to get your total. So your total quantity, your total product. And we don't care about this once the product has been found. This no longer matters, right? So that is a way to do those 3 steps in an orderly fashion on your paper that isn't all over the place like this was. All right, just make yourself a table. So let's do some of these. We've got a couple that we can do. Actually, we just have one that we can do, but I can pull another one out. So let me clear the page. Make sure you've written down this table of how to do it and your steps, okay? So let me clear the page. And let's do 52.5. And the problem, I'm going to go ahead and just type the problem for you. All right, so here's our problem. The average of the first 90 numbers was 4. The average of the next 10 numbers was 6. What was the overall average? So remember the format that we talked about. We want to do the quantity times the average. You would think I could write that. Average. And that's going to equal our product. So our first quantity is the first 90 numbers. So the 90 is the quantity, was 4. So the average was 4. The average of the first 90 numbers was 4. The average of the next 10 numbers was 6. So 10 numbers was the quantity and 6 was the average. Now we can do the multiplication. 4 times 9 is 36, so that's 360. 10 times 6 is another 60. So we add the quantity together and we get 100. And we add the products together and we get 420. Now we divide by 100 and we get 4.2 is our overall average. When you do it like that, it's pretty easy when you have a way to set it up and do it. All right, this was our total. All right, let me see if I can pull out another one. Let's do 52.6. And we are going to look. Let me type this one for you as well. So The average of the first 6 weights was 15 pounds. The average of the next 14 weights was 30 pounds. What was the overall average? So we set up our table. Quantity times average equals product. And we look first for our quantity. The first 6 weights, the average of the first 6 was 15 pounds. So the quantity is 6 and the average was 15. The average of the next 14 was 30. So now we multiply. 6 times 15 is going to be 3 times 30, so that's 90. And 14 times 30 is going to be 420, I think. Because that's the same as saying 7 times 60, because our factors are 7 and 2. I can take 2 times 30 and say 60, and 7 times 60 is 420. Sometimes it helps to break it down like that in your head. When you can break down into prime factorization, that's one of the benefits of knowing how to do prime factorization, is you can break your factors down and it makes it easier to multiply into a bigger number. Now I add my quantity together and I have 20 quantity. These are my totals. And my product is going to be 510. Now I just divide by my quantity, and my overall average is going to be 25.5. I'm going to double check that with my calculator. So 510 divided by 20 is 25.5. So 25.5 is my overall average. All right. So that is all we have for lesson 52. I will see you in lesson 53.